Hello everyone. Today we cover the topic of price bundling. First, let me explain what is price bundling. Price bundling is the tactic of marketing when two or more products or services are sold together for a price below the sum of individual prices. Here are some examples. The first type of price bundling is what we call pure bundling. In pure bundling, products can only be bought together. For example, when you go to a buffet, you cannot buy individual dishes. You pay for the cost and you can eat whatever you want. When you subscribe to Netflix, you don't get to pick and choose the shows you watch. You pay the cost and you can watch all the shows available on Netflix. This is what we call pure bundling. A second type of bundling is called mixed bundling. In mixed bundling, you can either buy the bundle or you can buy the individual products separately. Examples include you can buy the computer and the monitor separately or together, or some restaurants offer buffet and a la carte where you can order individual dishes. So in today's lecture, we're going to look at the implications of bundling on optimal prices and on how they change the total profitability. In these comparisons, the traditional pure component pricing, that is, individual products, will be used as the benchmark for evaluating the advantages of bundling. In the first example, let's say we have a movie distributor who's trying to sell two movies to movie theaters. The movies are Star Wars, The Last Jedi, and Pitch Perfect 3. And there are two theaters. So in this case, the business model is the theaters would buy the rights to show the movies, and then the theaters would pocket the movie ticket sales. So the two theaters, red and green, they serve different customers, and they are considering paying a lump sum money to buy the rights to show these movies. So in the first example, the two theaters, red and green, have the following willingness to pay for each movie. Theater Red is willing to pay $8,000 for The Last Jedi and $3,000 for Pitch Perfect 3. Theater Green is willing to pay $7,000 for The Last Jedi and $2,500 for Pitch Perfect 3. So for these willingness to pay for the two movies, the first question is, if the movie distributor is selling these movies to the two theaters, what is the optimal selling price for each movie? So the calculation here is fairly straightforward given everything we have gone through. For The Last Jedi, the distributor can charge two different prices, $8,000 or $7,000. If the distributor charges $8,000, only Theater Red would buy the rights to show the movie, and the distributor would pocket $8,000. If the distributor charges $7,000, then both theaters are going to buy the movie, and the distributor will pocket 7,000 times 2, that is $14,000. So in this case, the optimal price is $7,000, and both theaters would buy The Last Jedi. Similarly, we can calculate the optimal price for Pitch Perfect 3. And in this case, we can either charge $3,000 with only one theater buying, or $2,500 with both theaters buying. And obviously, $2,500 is the better price, and the distributor will pocket $5,000 with both theaters buying. So, for individual movies, the optimal prices are $7,000 for The Last Jedi and $2,500 for Pitch Perfect 3, and the total revenue that the distributor would pocket would be $19,000. That is $14,000 plus $5,000. So that is the optimal price and the corresponding revenue for individual movies. So the next question is, if the distributor offered one price for both movies, at what price would each theater buy them, and is bundling profitable? So the assumption we make is that the willingness to pay for both movies is the sum of the willingness to pay of each movie. Therefore, for Theater Red, The willingness to pay for both movies is $8,000 plus $3,000, and it's equal to $11,000. For Theater Green, the willingness to pay is $7,000 plus $2,500. That is $9,500. So once we calculate the willingness to pay, we can see that here $11,000, here $9,500, and the optimal price would be to charge $9,500, and both theaters will buy the bundle. The total revenue for the distributor is $9,500 times 2. That is $19,000. When we compare the results from the first question and the result from the third question, we can see that in both scenarios, the total profit is the same at $19,000. In other words, bundling is not more profitable than selling individual movies. Now let me make a small change in this example. I'm going to switch the willingness to pay $3,000 and the $2,500 between the two theaters. And now we have a new willingness to pay situation. So what you see here is everything else is the same. The only difference is these two willingness to pay numbers are flipped between the two theaters. And again, for question 1, what is the optimal selling price for each movie? The answer is the same as what we have seen before. We charge $7,000 for The Last Jedi and $2,500 for Pitch Perfect 3, and the total revenue is $19,000. Now, if we bundle these two movies together, what happens to the willingness to pay? For Theater Red, it's $8,000 plus $2,500. That is $11,500. For Theater Green, it's $7,000 plus $3,000. That is $10,000. So, in this case, is bundling profitable? With these two numbers, $10,500 and $10,000. So the optimal price is $10,000 and both theaters would buy. So in this case, under the optimal price, the total revenue would be $10,000 times 2, that is $20,000. Comparing that to $19,000 from selling individual movies, interestingly, in this case, bundling is profitable. I really didn't change the numbers all that much. Why the difference? So the key observation or insight on this is when the willingness to pay for component products are negatively correlated, it creates an opportunity for bundling. Again, let me show you these two willingness to pay tables. When I say negatively correlated, what I meant is, when you look at the first table, Theater Red is willing to pay a higher price for The Last Jedi, $8,000 versus $7,000, and a higher price for Pitch Perfect 3, $3,000 versus $2,500. So the willingness to pays are positively correlated. That is, if you are willing to pay higher for one movie, you are also willing to pay higher for the other movie. However, in the second table, Theater Red is willing to pay more for Jedi, but Theater Red is willing to pay less for Pitch Perfect 3. That is, when you are willing to pay higher for one product, you are willing to pay lower for the other product. So that's what I meant by the willingness to pay for component products are negatively correlated. And because of the negative correlation, what happens is bundling can improve profit because the unexploited consumer surplus. That is, we're transferring the money left on the table for this product to the lower willingness to pay in the second product. So when the two combine together, in the total, they are averaged out. That's how bundling works. So keep in mind about the negative willingness to pay correlation. Now let me show you a second example. So in this case, we're planning for 2 concerts. a theater is considering two concerts this season, Taylor Swift and the Rolling Stones. So the question for the theater is what prices should be charged for these concerts? And the assumptions, just to simplify the calculation, although the fixed cost for providing the concerts is substantial, the unit variable cost per customer is actually pretty low. So for calculation's sake, we assume the variable cost is zero. Now here is the willingness to pay table. We have four segments: teenagers, college students, young adults, and parents. And their willingness to pay for a Taylor Swift concert versus a Rolling Stones concert are as follows. So teenagers are willing to pay $90 for Taylor Swift and $15 for the Rolling Stones. College students are willing to pay $80 for Taylor Swift and $50 for Rolling Stones. Young adults, $45 for Taylor Swift, $85 for Rolling Stones. Parents, $25 for Taylor Swift and $90 for Rolling Stones. When you look at these willingness to pay numbers, the first impression you can form here is, are these willingness to pays negatively correlated? You don't have to run a statistical correlation. You can kind of see it right here. So you can see that the willingness to pay from high all the way to low on Taylor Swift and from low all the way to high on Rolling Stones. So they are actually going in different directions. So we can see that these willingness to pay numbers are negatively correlated. So that's the first condition that we want to examine for the possibility of bundling and improve profitability. So the next thing we want to do for preparation purpose is, since we are going to look at bundling prices, so we're going to calculate how much these four different segments are willing to pay bundles of the concerts, assuming the willingness to pay for the bundle is the sum of the willingness to pay for each individual component. So to calculate this, for teenagers, 90 plus 15 is 105 for bundle. College students, 80 plus 50 is 130 for bundle. And young adults, 45 plus 85 is again 130 for bundle. And parents, 25 plus 90 is 115 for bundle. So having calculated that preparation, and we also know that the four segments are of equal segment sizes of 1,000 people each. Given this table that we have already prepared, what are the optimal prices for selling individual concerts separately? Second, selling a pure bundle of the two concerts together. And third, when offering individual concerts and the bundle into the market. So next, we are going to do a calculation to answer these three questions. First, we'll look at selling individual concerts separately. Here, the possible price levels are based on the willingness to pay. For Taylor Swift, the prices are 90, 80, 45, and 25. And then we look at each different price levels, what are the demand levels? So at $90, only teenagers will buy, that's 1,000. And similarly, we get the demand going up to 2,000, 3,000, 4,000. And correspondingly, the revenue is the price times the demand. So we get $90,000, $160,000, $135,000, and $100,000. Out of this, $160,000 is the highest revenue. And for Rolling Stones, the possible price levels are 15, 50, 85, and 90. And the corresponding demand levels are 4,000, 3,000, 2,000, and 1,000. Then we calculate the revenues: $60,000, $150,000, $170,000, and $90,000. Here, $170,000 is the highest revenue. So in total, if we sell these concerts separately, we have $330,000. These are the optimal prices. And next, we're going to look at the optimal price for selling bundles. For bundle pricing, we have three different possibilities: 105, 115, and 130. The corresponding demands are 4,000, 3,000, and 2,000. So then we calculate the revenue. They are $420,000, $345,000, and $260,000. And $420,000 is the highest revenue, so the bundle price should be 105. Finally, we look at the optimal price for mixed bundling. We offer all three different things into the market. The trick here is to look for the high spots on willingness to pay. We can see that teenagers are willing to pay $90 for Taylor Swift. Parents are willing to pay high for Rolling Stone, and the two other segments are willing to pay higher for bundles. Therefore, we can check for Taylor Swift at $90 and Rolling Stone at $90. They take care of the teenagers and the parents segments, and then we charge $130 for bundles for college students and young adults. In total, we would have $90,000 plus $90,000 and plus $260,000. We have $440,000 in total. All right, now we have done the calculation. Here is a summary of the results. When we sell individual components only, the optimal prices are $80 for Taylor Swift and $85 for Rolling Stones. So we're selling 2,000 of each, and the total revenue is $330,000. And the sales revenue index, if we index this as 100, then pure bundling, we're charging a price of $105, and all four segments are going to buy the pure bundling, and the total revenue is $420,000. Comparatively, this is an improvement of 27% on revenue. And finally, in mixed bundling, we charge $90 for Taylor Swift, $90 for Rolling Stone, and $130 for bundle. So we have a segment buying Taylor Swift, a segment buying Rolling Stones, and two other segments buying the bundle. And the total revenue is $440,000, and it is a 33% improvement comparing to the baseline condition in total revenue. As you can see, bundling can be highly profitable. And lastly, a cautionary note on bundling. There are legal restrictions. The most famous landmark case was when Microsoft was bundling its internet browser, the Internet Explorer, with the Windows operating system. And as a result, Microsoft was sued by the Justice Department of the federal government for abusing monopoly power. And Microsoft lost the lawsuit, and that lawsuit was kind of the turning point for Microsoft. From there on, the company started to lose its edge for innovations because of various restrictions, and they have to be very cautiously treading the water here. That's all for bundling. Thank you. I'll see you next time.